1.8, we're going to be looking at higher order derivatives. Higher order derivatives. So let's start with f of x equals to x to the fourth. Let's take the derivative. F prime of x equals 4x cubed. Let's take the derivative of the derivative. We'll call this f double prime of x. So we'll take the derivative of 4x cubed, 3 times 4 is 12, and we have 12x squared. Okay, in your groups, can you do this problem? Triple prime. Okay, very good. So 2 times 12 is 24, 24x. All right, now we're going to look at a problem that's written a little bit differently. And this says d4 dx to the fourth. And all this means is we're going to take the derivative 4 times, okay? And we're going to take it for 2x to the fifth. All right, so y prime is going to be our first time, which would be 10x to the fourth. Y double prime, 4 times 10 is 40, x to the third. Y triple prime, 3 times 40 is 120, x squared. And y quadruple prime, 2 times 120, 240, x. Okay, good. All right, now we're going to use the higher order derivatives in a word problem. Okay. All right, so here's the example. A rock drops from a 144-foot building. A rock drops from a 140-foot building and can be modeled by this equation. S of t equals 144 minus 16t squared. Okay, in this case t is in seconds. I'm leaving this space here because we're going to draw a graph. T is in seconds, and S of t is in height. I'm just going to put like this, is height, and that's in feet. Okay, so let's draw a picture of this. You can just go out 3 seconds. 1, 2, 3. We're looking at seconds. So this is going to be t, the horizontal axis. And the vertical axis is going to be s of t. And it's going to be height in feet. Okay, it says a rock drops from a 140-foot building. If we put a 0 in here, put a 0 right there, we get 144. So this is the top of the building, 144 feet. All right, so we're going to draw a picture. It kind of looks like this. It's falling, it's not falling straight down. It's almost like it's falling, 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 and hits. Okay. What is the rate that it's falling? Well, we take the derivative as prime of t, and that gives us negative 32 t feet per second. Okay, we call this velocity, the rate at which it's falling. And v of t, which represents velocity, equals s prime of t. Okay, so we can finally say v of t is negative 32t feet per second. Okay, well, we can go a bit further. How about the acceleration? Acceleration we call a of t. And it turns out that the acceleration is the derivative of the velocity. Okay? So basically, the acceleration is the derivative of the velocity, and the derivative of negative 32t is just negative 32. And we word that as feet per second squared. Feet per second squared. Okay. So let's kind of write in one line how we're going to use this. So we know a of t is the first derivative of v of t, and that happens to equal the second derivative of s of t. Okay, so this is good to know. All right, so we're going to do a problem where we use all three of these. An object free falls. And here's the model for it. S of t equals 4.9 t squared. 4.9 t squared. And again, t is in seconds. And S of t is in meters. Okay, letter A, find. All right, find how far an object has traveled. Find how far an object has traveled after 5 seconds. All right, so we're looking how far. S is in meters, and we know we have 5 seconds, so we're going to use this right here. So we have S of 5 equals 4.9 times 5 squared, which is 4.9 times 25, which is 122.5 meters. Okay, let's move on. Find the velocity. And the velocity the object is traveling. Find the velocity the object is traveling. Well, we know v of t equals s prime of t. S prime of t, well, here's s of t. So s prime of t, we're going to go ahead and bring down the 2, bring down this 2, and we get 9.8 t. And that is in meters per second. Okay, so find the velocity the object is traveling at 5 seconds. We would put in 5 into the velocity, which is 9.8 times 5, which is approximately 49 meters per second. Okay, one last one, C. The object's acceleration. The object's acceleration after t seconds is constant. The object's acceleration after t seconds is constant. Find the acceleration after 5 seconds. right? Well, what do we know? We know a of t equals s, not s, v prime of t. All right? And v prime of t we said was, we didn't do it yet. Here's v of t, 9.8t. So to take the derivative of v of t, that is a of t, is just 9.8. 9.8 meters second squared. Okay, so the question says find the acceleration after 5 seconds. But remember, it stated the object acceleration after t seconds is constant. And this is just a constant number. So a of 5 will also equal 9.8 meters second squared.